Table of Contents. About the authors. Preface. Acknowledgements. Chapter 1. Introduction. Read the book, not the spec. SYCL 1.2.1 versus SYCL 2020 and DPC++. Getting a DPC++ compiler. Book GitHub, Hello, World, and ASYCL program dissection. Cues and actions. It is all about parallelism. Throughput, latency, think parallel. Amdahl and Gustafson. Scaling, heterogeneous systems, data parallel programming. Key attributes of DPC++ and SYCL single source. Host, devices. Kernel code, asynchronous task graphs, C++ lambda functions. Portability and direct programming. Concurrency versus parallelism. Summary. Chapter 2. Where code executes. Single source, host code, device code, choosing devices. Method number 1. Run on a device of any type. Queues, binding a queue to a device when any device will do. Method number 2. Using the host device for development and debugging. Method number 3. Using a GPU or other accelerators. Device types, device selectors. Method number 4. Using multiple devices. Method number 5. Custom, very specific, device selection. Device_selector base class. Mechanisms to score a device. 3 paths to device code execution on CPU creating work on a device. Introducing the task graph. Where is the device code? Actions, fallback, summary. Chapter 3. Data management. Introduction. The data management problem. Device local versus device remote. Managing multiple memories. Explicit data movement, implicit data movement. Selecting the right strategy. USM, buffers and images. Unified shared memory. Accessing memory through pointers. USM and data movement. Buffers. Creating buffers. Accessing buffers. Access modes. Ordering the uses of data. In order queues. Out of order, OOO, queues. Explicit dependencies with events. Implicit dependencies with accessors. Choosing a data management strategy. Handler class. Key members. Summary. Chapter 4. Expressing parallelism. Parallelism within kernels. Multidimensional kernels. Loops versus kernels. Overview of language features. Separating kernels from host code. Different forms of parallel kernels. Basic data parallel kernels. Understanding basic data parallel kernels. Writing basic data parallel kernels. Details of basic data parallel kernels. Explicit ND range kernels. Understanding explicit ND range parallel kernels. Writing explicit ND range data parallel kernels. Details of explicit ND range data parallel kernels. Hierarchical parallel kernels. Understanding hierarchical data parallel kernels. Writing hierarchical data parallel kernels. Details of hierarchical data parallel kernels. Mapping computation to work items. One-to-one mapping. Many-to-one mapping. Choosing a kernel form. Summary. Chapter 5. Error handling. Safety first. Types of errors. Let's create some errors. Synchronous error. Asynchronous error. Application error handling strategy. Ignoring error handling. Synchronous error handling. Asynchronous error handling. Errors on a device. Summary. Chapter 6. Unified shared memory. Why should we use USM? Allocation types. Device allocations. Host allocations. Shared allocations. Allocating memory. What do we need to know? Multiple styles. Deallocating memory. Allocation example. Data management. Initialization. Data movement. Queries. Summary. Chapter 7. Buffers. Buffers. Creation. What can we do with a buffer? Accessors. Accessor creation. What can we do with an accessor? Summary. Chapter 8. Scheduling kernels and data movement. What is graph scheduling? How graphs work in DPC++. Command group actions. How command groups declare dependencies. Examples. When are the parts of a CG executed? Data movement. Explicit. Implicit, synchronizing with the host. Summary. Chapter 9. Communication and synchronization. Work groups and work items. Building blocks for efficient communication. Synchronization via barriers. Workgroup local memory. Using workgroup barriers and local memory. Workgroup barriers and local memory in ND range kernels. Workgroup barriers and local memory in hierarchical kernels. Subgroups. Synchronization via subgroup barriers. Exchanging data within a subgroup. A full subgroup ND range kernel example. Collective functions. Broadcast, votes, shuffles, loads and stores. Summary. Chapter 10. Defining kernels. Why 3 ways to represent a kernel. Kernels as lambda expressions. Elements of a kernel lambda expression. Naming kernel lambda expressions. Kernels as named function objects. Elements of a kernel named function object. Interoperability with other APIs. Interoperability with API-defined source languages. Interoperability with API-defined kernel objects. Kernels in program objects. Summary. Chapter 11. Vectors. How to think about vectors. Vector types. Vector interface. Load and store member functions. Swizzle operations. Vector execution within a parallel kernel. Vector parallelism. Summary. Chapter 12. Device information. Refining kernel code to be more prescriptive. How to enumerate devices and capabilities. Custom device selector. Being curious. Get_info. Being more curious. Detailed enumeration code. Inquisitive. Get_info. Device information descriptors. Device-specific kernel information descriptors. The specifics. Those of correctness. Device queries. Kernel queries. The specifics. Those of tuning, optimization. Device queries. Kernel queries. Runtime versus compile time properties. Summary. Chapter 13. Practical tips. Getting ADPC++ compiler and code samples. Online forum and documentation. Platform model. Multi-architecture binaries. Compilation model. Adding SYCL to existing C++ programs. Debugging. Debugging kernel code. Debugging runtime failures. Initializing data and accessing kernel outputs. Multiple translation units. Performance implications of multiple translation units. When anonymous lambdas need names. Migrating from CUDA to SYCL summary. Chapter 14. Common parallel patterns. Understanding the patterns. Map, stencil, reduction, scan, pack and unpack, using built-in functions and libraries. The DPC++ reduction library. ONIA PIDPC++ library. Group functions. Direct programming. Map, stencil, reduction, scan, pack and unpack. Summary. For more information. Chapter 15. Programming for GPS. Performance caveats. How GPS work. GPU building blocks. Simpler processors, but more of them. Simplified control logic, SIMD instructions. Switching work to hide latency. Offloading kernels to GPS. SYCL runtime library. GPU software drivers. GPU hardware. Beware the cost of offloading. GPU kernel best practices. Accessing global memory. Accessing workgroup local memory. Avoiding local memory entirely with subgroups. Optimizing computation using small data types. Optimizing math functions, specialized functions and extensions. Summary. For more information. Chapter 16. Programming for CPS. Performance caveats. The basics of a general-purpose CPU. The basics of SIMD hardware. Exploiting thread-level parallelism. Thread affinity insight. Be mindful of first touch to memory. SIMD vectorization on CPU ensure SIMD execution legality. SIMD masking and cost. Avoid array of struct for SIMD efficiency. Data type impact on SIMD efficiency. SIMD execution using single underscore task. Summary. Chapter 17. Programming for FPGAs. Performance caveats. How to think about FPGAs. Pipeline parallelism. Kernels consume chip area. When to use an FPGA. Lots and lots of work. Custom operations or operation widths. Scalar data flow. Low latency and rich connectivity. Customized memory systems. Running on an FPGA. Compile times. Writing kernels for FPGAs. Exposing parallelism. Pipes. Custom memory systems. Some closing topics. FPGA building blocks. Clock frequency. Summary. Chapter 18. Libraries. Built-in functions. Use the SYCL prefix with built-in functions. DPC++ library. Standard C++ AP is in DPC++. DPC++ parallel STL error handling with DPC++ execution policies. Summary. Chapter 19. Memory model and atomics. What is in a memory model? Data races and synchronization, barriers and fences, atomic operations, memory ordering, the memory model, the memory_order enumeration class, the memory_scope enumeration class, querying device capabilities, barriers and fences. Atomic operations in DPC++. Using atomics in real life. Computing a histogram. Implementing device-wide synchronization. Summary. For more information. Epilogue. Future direction of DPC++. Alignment with C++PLUS20 and C++PLUS23. Address spaces. Extension and specialization mechanism. Hierarchical parallelism. Summary. For more information. Index.